All right, everyone. Let's see. Can I mute the? Okay, never mind. I'll just leave the other ones. Oh, so good evening, everyone. Hello from the Atlantic Ocean. I'm Dr. Neitzke Adamo. I'm the director of the Rutgers Geology Museum, and I am on the ship with about 50 crew, science team, and educators, where we are coring, collecting cores on the continental shelf and slope off of Canada right now. And yeah, we're collecting cores that are going to be analyzed for climate change. And if you want over here, we have the chief scientist with right now. Say hi.
Hi, everyone. So I'm Julian, and as Lauren told you, we're out here in the North Atlantic Ocean, a few hundred miles or so from the United States, and we're collecting mud. And what are we doing with that mud? Well, we are trying to understand how the climate changed in the past before people started causing changes to the climate. It's really important to know what the natural variations are in Earth's climate before you can say with confidence that it's changed because of humans. So that's really what we're doing out here. And I know you guys must have lots of great questions. So should they fire away?
Not yet.
Oh, don't fire away yet.
Yeah. Well, I'm gonna go through some slides and show
Okay.
you the ship,
Okay.
and then we'll come back for questions.
Sure.
So,
And I'll be here in case anyone wants to ask me a question.
yes, please. So if you are joining us, watching us on Facebook Live or on the webinar, just put your questions in the chat, and we will get them and answer them. So we have a few slides that I wanted to show you put together by Stacy. Wave hi, Stacy. She's right there. She took pictures of various parts of the ship so that you can see what it looks like living on the ship and some of the things that we're doing. Okay, let me go to the next slide. Okay, so we are on the RV Atlantis. Here's some facts about her. Let's see if I can see she's about, was it 270 feet long? Is that? Yeah, 274 feet long. This ship is owned by the Navy, but it is operated by Woods Hole Oceanographic Institute. So we actually left Woods Hole, Massachusetts Friday morning, and then had 2 days at sea on Atlantis, and now we're finally coring. Okay, so more stuff about the ship. Okay, so here's the one I was asking. 83.2 meters. That's in scientific meters versus 274 feet. So usually the Atlantis tenders the Alvin, which is a submersible, like a submarine that goes down in the ocean and explores things on the ocean floor. The Alvin is currently being upgraded and retrofitted, and things are, engineers are working on it. So that the Alvin is not on the ship with us right now. It's back at port at Woods Hole. So that is why we are on the ship and got to go sailing now, because the Alvin is being repaired. So they were filling the schedule of cruises with other cruises like this, the coring cruise. Okay, like I said, there's about 50 scientists, crews, technicians, teachers, etc., all together. Okay, so we have a lot of space on the ship to do our work. So we have several labs. So on this side, you can see the main lab. This is during when we were unpacking. And this is where we spend probably most of our time working. This is where things are sampled. The core is described. We started with core and mud earlier today. We're describing and sampling core. There's also a wet lab, which is over here. This is the one that we get really dirty in. So when we take multi-cores, which I'll show you a picture of, these are put in pieces and stuff in there, and we get lots of mud all over the place. So Ale has brought over, say hi, Ale. This is one of our teachers. So this is one of the cores that was collected, I think, yesterday. And we split today. and we describe it. And you can see these little marks in here. This is where they took up that are going to go back to the lab. And you might not be able to see it on the computer, but there are slight color changes in the core. So this part right here is more like reddish brown. This is more like grayish brown. So there are some significant color changes in the core. Thank you. So we are waiting for a core to come back up from the ocean right now. We have a multi-core that just hit bottom not too long ago and is on its way back up to the ship. So when it gets on board, there will be a flurry of activity of people collecting and organizing. And so we're not done our work today after we finish this webinar. We all have lots of science to do after this. Okay, so some more things that you find on the ship. We have a computer lab. So the computer lab is where a lot of the work is done to determine where we're going to core. This is also has monitors and sensors that tell us when the core is going to hit the bottom of the ocean. And then, so a lot of people sit in this room not only to figure out where to core, making sure that the operations are working as they should, as the core is going down to the bottom of the ocean and as it's. So these things in the middle are called plane pumps. So these are pumps that are put down into the water for several hours, and they pump water through them to collect particulates that are in the water. And then those particulates are analyzed in the lab. The CTD machine, this is another thing that goes down into the bottom of the ocean. It doesn't hit the floor, it doesn't collect water. What it does is it collects water. So in those bottles that you see along here, they have numbers on them. It's up to 24, is that right?
Yeah.
Yeah, there's 24 bottles around this whole thing. As it goes down, there's a trigger on the top that triggers closing one of the bottles one at a time. So that way, as you go down, you can collect water from the top of the ocean through all the intermediate to the bottom. So scientists then collect that water and they analyze the water from the different depths. Okay, so these are some pictures of the Alvin. Again, the submersible, pretty famous submersible, responsible for discovering deep sea volcanic vents. Lots of awesome science done by that, but he's at his ship, so we will not be able to go down in the submersible on this cruise. Okay, so these are just some other things that you can see on the ship. So is that crane the one that loads the ship, I think, right? The first one, the red? That's on the dock. Yeah, so this first one in the red crane, that's the crane that lifts the supplies from the dock. You can see the dock behind it, lifts it onto the boat. So all the stuff and all the things that we need, the food, we're all happy that the crane lifts all the food onto the ship, and also the scientific equipment that we'll need for the 2 weeks that we are at sea. And then this crane here in the center is actually attached to the ship. That doesn't move. That stays there, and that is the crane that lifts the Alvin up into the water and back onto the deck. So we are actually not using this crane on this trip because we don't want to damage it for the Alvin. We are using a crane that's over the side of the ship. Okay, and so in this last picture here, you can see everybody in the computer lab. See, everyone's looking at the screens. This is where they are watching the core go down from the, what's it called, the sensors, to make sure that it's hitting the bottom correctly and coming back up. So lots of stuff is decided in that room. Okay, so these are just some of the things that use for coring. The first one on the left in the red box is the gravity core. So we put about 20 feet of PVC pipe, which you can see right here, together, and that goes inside that red barrel that you see here. And then the crane is the gray machinery behind it. It lifts, well, the bottom of the core gets lowered there, and then the bucket, which is this yellow thing right here, holds it upright, and then the crane lifts it up out of the bucket over to the water and then drops it down. Okay, and there is a big spool of metal cable that I asked him how much cable is in it. He said when that cable spool is new, it holds about 10,000 meters worth of metal cable. So it has a lot of cable that can make it go all the way down to the ocean floor, depending on what depth you are coring at. Okay, the multi-core, it looks like a big upside down ice cream cone. The
Spider.
A spider. Yeah, it does look like a spider web too. But in the center, you can see that there are these tubes right here. Okay, these are the multi-cores, and the purpose of the multi-core is that this spider web ice cream cone gets set down gently on the bottom of the ocean, and then the center part will gently push into the sediments, and so that it only takes maybe a couple feet of sediment, and then also capture the water at the top of the sediment. And the reason for this is because when you push these other cores into the bottom of the ocean, it hits with such impact that it blows the top of the sediment away. So the multi-core is used with the other type of core so that you can capture that first couple centimeters of the bottom of the ocean. And when we bring this up, we get 8 little cores. Okay, so this is the thing that is on its way back up from the ocean floor right now. And we will be spending the next couple hours tonight slabbing and bagging and sampling the cores from the multi-core. Okay, so here's a picture. You can see like what I was explaining, that the metal tube goes down and then the crane lifts the weights out of the basket and over to the side of the ocean. You can see this is before it's starting to go down. This is one of the life rafts that is on the ship. And here you can see isn't an emergency while they're in there. This was actually a safety drill. So some of the crew had to do some safety drills of practicing moving the lifeboat from the deck over into the ocean, driving it around and making sure the boat worked. So that was a safety drill that they did yesterday with the life raft. Okay, some more pictures. So this is the view from the bridge, so where the boat is dry. So you can see the captain's chair, the navigation, all the equipment that is used to navigate this big boat to where it needs to go. And there's always somebody on duty 24 hours a day at the bridge that's watching all of the data and all the incoming stuff to make sure that everyone is safe while on the ship. And then here's just a nice panoramic view of looking of all the equipment in the ship. And you can see the windows out, looking out at the ocean in front of it. Okay, a lot of people want to know about what do we do for eating, sleeping, entertainment. So we are working a lot. We all work about 12-hour shifts while we're here, sometimes a little bit more, because when the core comes up, you got to get that work done right away. But between that, we do have some downtime, and we do all love our meals on ship. So there is a crew of 3 who make all of our meals. They make breakfast, lunch, and dinner for us. They always post a menu there. And there's usually several entrees and sides, and there's always fresh dessert every day. So the cooks have been absolutely amazing, keeping all of us fed and watered. So, and then there is like, here you can see with all where we eat our meals, and just beyond that, you can see the bookshelves. That is the library, where there's more tables and chairs and lots of books that anybody can borrow or share for entertainment. So what our living quarters look like. This is an example of one of the berths. I think Stacy's is your room. Yeah, Stacy and Ale, it's their room. So we do have bunk beds. One of us is on the bottom, one is on the top. I have a top bunk, which is it's comfy. Once I'm in there, I fall asleep, but I'm having trouble getting in and out. I hit my head on one of the things in the, the bunk last night as the ship was moving, so it is a little bit of adjustment. But that's what we call home for the next week or so. And then also the shared bathroom. So you can see the bathroom, and there's a berth on either side. So 4 people are sharing one bathroom. And then in the middle, you can see that's our movie room. And they have over 12,000 DVDs on the ship with a very large TV. So there's lots of stuff to keep us entertained. We cannot stream Netflix and things like that because the internet cannot handle that much bandwidth by doing that. So anything that we wanted to watch on Netflix or whatever, we had to download before we left port to watch it. Otherwise, there's lots of movies that we can go get to keep ourselves entertained. Okay, other things. We get dirty. We're out here, very dirty, lots of mud. So there is a laundry so that you don't have to have new clothes for every day. So I've already done laundry once. I think most people have done it once. I probably will do it a couple times because I didn't bring enough clothes for 14 days. I brought a couple pairs and just wash it. There is a gym where you can see in the center picture, there's a treadmill, I think there's an elliptical, there's some weights for lifting if you want to do that. And there's a hospital on board. So they have a fully stocked hospital with lots of equipment. They have designated crew who handle the medical issues. We don't have a doctor on the ship. But what we do is if there's something would come up, they would connect with a doctor on shore and they would triage them over the phone or over the computer. And then they have a lot of stuff on stock on the ship to help for most things that will happen. Obviously, if something was a true emergency, then we'd have to consider other things. But we just hope that that doesn't happen. So, but minor things do happen while you're at sea. Okay, so other things for safety. The crew always stresses how important it is to be safe at all times. So if we are out on deck, so outside, we're in the lab right now, but if we are on the deck where the coring is done, you always have to wear steel-toed boots. So this would be shoes or boots that the front of the toe is metal so that you don't crush your feet. We also have to wear our hard hats while we are out doing work because there's lots of stuff overhead, tools and wires and things like that. So we have to wear that to protect ourselves.
You should show them how they're doing that.
Oh yeah, can one of you? Here it goes. So they are getting ready to go outside to work on deck. So we will show you what they look like. You want to tell them what you're wearing for safety.
Okay, we'll start with a hard hat here. So going outside, we have to protect our heads because some of the wires could catch and like break tension and then it could hit us. So or anything falling down, this hard hat will protect your head. It won't crush your face, won't crush your head. And then
life jacket. It's got a little light on here. It's water activated. Turn off by pressing that. Important straps and pockets to hold tools.
A whistle.
And then we also have, you can't see it, but we have steel toe rubber boots. Yeah, there's that. So we have that. It has to be steel toe because things could fall on your shoes or on your foot and could your toes. But if you have steel toe, you got extra protection.
Yeah.
These work vests are actually a special type of flotation. They're not quite as bulky as a proper life jacket. And so you'll see a lot of them, it says work vest only. So it's not meant to be your primary means of flotation, but it's not as bulky as a life jacket, so you can still get what you need done, but it offers some protection if someone were to fall in to help keep you afloat till you can get
or if
pulled back out.
some kind of machine knocks you over, right?
Yeah.
Knocks you overboard. So thank you. We'll be out there to help you soon. All right. This is nice how everyone's walking by, so you get to see lots of the different staff. So that was all members of the science team. They are going out, getting ready for the multi-core to get back on deck. How far away is it? Do you know? Yeah, so it takes about an hour and a half for the core to go where we are now, because we're in a very deep location, about an hour and a half for it to go down, and then another hour and a half to come back up. So everyone's anxiously waiting for it to come back up on board. Other things for safety, we all had to participate in a safety drill on our first day at sea. In this picture here, you can see all of us wearing our flotation devices. We were told to bring a hat because if you really had to abandon ship in an emergency, you would want to have a hat to protect your face from the elements. And then here's Stacy in the middle looking very uncomfortable with her immersion suit. You feel like a true emergency, this suit keep you afloat and it would keep you dry. The two things to do if you had to abandon ships. They're hot and it's very hard to move in them. So every single person in the science crew had to put on their immersion suit with this safety drill to make sure that it fit. We needed to know where. If something were to happen, this is where you muster. So they told us, you know, based on if left on the top bunk or the bottom, we'd have to go muster the first day. Before we started coring yesterday, we had 2 days at sea to entertain ourselves. So we spent some time with the core techs and the techs that work on the ship, and they went over and different steps taken, how to put together the tubes, how to label things correctly. So we had a training the first 2 days here. We also had a lot of downtime. The first day, you can see us all looking over the bow of the ship because as we were steaming, hundreds of dolphins were swimming alongside the ship with us. We were all looking out the side. It was amazing. And then we also have been doing some fun things. We were all deck divers, so I'll explain why in a little bit, but we had a big arts and crafts party in the main lab for the couple of days that we were staying. Oh, this is why. So these are the styrofoam that we colored. Some of them, a lot of these were colored by either children or school children back at home at their various schools, and some were colored by us. So the reason why we use styrofoam is we know as you go farther down in the ocean, the pressure increases. And if you send styrofoam down attached in a bag to one of the cores, it actually shrinks the styrofoam from the pressure under the water column. So I'll show you. So these are some squished styrofoam cups. So see how big it is compared to my hand? So this was a full-size cup. It was not, it was probably about this tall, 6 to 8 inches tall, and then this is what it shrunk to. So we have a whole bunch of these really cool styrofoam cups, and we've had some styrofoam heads that were shrunk. So again, you can see this is what it looked like after that we shrunk all hundreds of cups. And we have some more that will be shrunk. This one's a cool one. Oh, it has a little octopus on it. So very cool, little tiny cups. Thanks, Kelly. So we had our first mud yesterday, and we were all really excited. As you can see, Mirko, who you met just a minute ago, very excited, touching the mud. We were all out there feeling the mud, looking at it, and very excited to bring up our first gravity core, which you see in this middle picture here. And that's actually the core that was split today that Ali showed at the beginning from the first mud. And then this is the multi-core. This is in the wet lab. That's the one that gets super dirty, super messy. It's like a big push pop. We put it on the stand and we push the core down, and we get little slices of mud and bag them into baggies. Sure. So this is some of the mud from that core that we just showed you. We had to clean up the core because when you split them open, they don't look perfect. So we have to scrape them off to be able to photograph them. But this is what some of the mud looks like. So this mud is a reddish brown, dark brown with a hint of red in it. So the teachers are taking some of this mud home to show their students. Okay, so here's just another fun panoramic showing the 20-foot gravity core. So this is the PVC tube that we put together, and it hasn't been filled with mud yet, obviously. Because there's a lot of things that have to happen to prepare to go get the mud. So this is where they were putting it together, and then they have to label it with all the correct numbers so you know exactly which section, which part of the core it is once it's filled. Okay, so here's pictures from today of the gravity core being sampled and cleaned up and described. So that was what we all did this afternoon. And again, if you look here, you can see there's one core here and another core here. You can see it's all mucky and whatever. So that's what this mud is. We have to scrape off the top so that we get it to look all nice and neat here, so that the scientists can then go through and describe all the different changes they see in the core. So we spent a lot of time doing that today. And most likely we will do it again tomorrow because a gravity core came up today. So we will have to split and clean it and describe it and sample it all tomorrow. So we will be busy. There's always something to do. Okay, another fun thing that the crew has been participating in is our species search. So we've seen a lot of sea creatures. We've seen some sea mammals. We saw dozens of whales yesterday, which I can't show you the video now, but in a day or two, there will be a really amazing video of these whales swimming inches away from that lifeboat that I showed you earlier. So Ollie's putting together the video. She's our cinematographer on the ship. She makes all the awesome videos you'll see on our blog. But you'll get to see the video footage of these whales swimming right next to the safety boat. It's amazing. I already told you we saw hundreds of dolphins swimming alongside the boat, which is also amazing. And then we have a lot of bird watchers on the ship too, who are trying to identify all the birds that they see. So here's just one example. The great shearwater is one of the birds that we saw, around the ship. So more to come. So yeah, that is what life is like.
Do you want to take them outside?
Yeah, hold on, let me end the slideshow and stop sharing. Okay, so I'm going to walk you over to outside before I answer questions. Sorry, as the ship rolls, we have to time our steps so we don't fall over. Okay, so here's the ocean behind us. It's just about sunset time here. That's why it's so dark, but we've had very calm seas. You see there's hardly any white caps. So right here, oh look, they're bringing something up. Here's the CTD. That is the one that collects the water. They can't get too close because but it looks like they're loading something with the core right now. So that is the gravity core over the side and the crane. Say hi. Say hi. Okay. All right, we'll go back inside. We can't go any farther because one, our internet signal will die, and two, they are actively using the crane, so we are not allowed to walk into the spaces when equipment like that is going because it's a safety hazard. Okay, let me pull up the questions. Okay. So if you have questions, please put them in the chat or put them on the chat on Facebook or in the chat here. So we have a couple questions. I'm going to read the questions and I'll let Julian answer them. So I'll read. You want to sit and I'll read it to you?
Sure.
Okay. So first, will the ocean be where the cores are collected?
Oh, that's a great question. So we are now taking our cores from the deepest area that we'll be sampling, and it's about 3,700 meters deep. So that is almost 3 miles. So it's quite deep, and this is probably as deep as we're going to go on this cruise. But just so you know, the ocean gets much deeper than 3,700 meters. There are places in the world ocean where it's more like 8,000 meters deep. But anyway, the deepest we're going is 3,700 meters.
Sure. How far from the shore are we?
Oh, that's another good question. I haven't done the recent calculation, but we're about 200 miles east of Nova Scotia. That would be the closest land, I think, It's possible that we're closer to Newfoundland right now, but I'm not certain.
Why did you choose this job as your career?
Oh, I like that question.
That's a great one. Well, grew up spending my summers on Cape Cod. Fell in love with the ocean as a kid. Used to drive by Woods Hole Oceanographic Institution many times a year as a child. And the ocean is just, it's fascinating. You know, our planet's 70% covered in water, and yet so much of the ocean remains unexplored. It's very hard to explore the interior of the ocean. There's no light. Electromagnetic radiation doesn't penetrate through water, so you can only use sonar or sound waves. And as you, very few ways to actually view the seafloor. Alvin is one of them, but there aren't many Alvins in the world. So some combination of loving to be near the ocean and being great unexplored area of our planet always attracted me to it.
Gracie is 8 years old, and she would like to know if any of us have gotten seasick. So how are you doing, Julian?
Well, I'm an oceanographer, and I do get seasick. I'm wearing one of these funny-looking patches behind my ear that help alleviate the symptoms of seasickness, but I've actually felt quite fine on this cruise because we've been very fortunate to have very calm seas, very little waves out here. So I personally have not felt seasick.
There have been a couple who have gotten sick.
There have been a couple
Yes,
people who
yes,
have gotten sick. Yeah.
Aaron.
I did get seasick. I do have the patch on as well, but it was only one evening, and I am doing much better now. So I found my sea legs.
Do you have another question?
I have a couple. Do you have? No. Okay. What are you looking for in the gravity cores?
Yeah. So the gravity cores, I think as Lauren explained, they bring back something like 20 feet, 15 or 20 feet worth of sediment from below the seafloor. And because they're so long, it's actually a time history that goes way back, probably tens of thousands of years, maybe even as much as 200,000 years. We won't know until we get these gravity cores back to our lab and can do some dating of them to see where we are in time. But ultimately, we want to get a nice long time history of how the temperature of the ocean has changed.
What part of New Jersey will we be closest to?
It looks like we'll be closest to the southern half of New Jersey. So Atlantic City, maybe. I don't know New Jersey that well, but the southern, we'll be off the southern half of New Jersey. Again, approximately a couple hundred miles offshore.
How many days are we going to be there? Like, how many days from now?
Oh, we will, if all goes as planned, we will finish up here near Nova Scotia on Thursday, and then we will do a transit where the ship's not going to stop. It's just going to go straight to the New Jersey area, and that'll get us, that's 2 days, so it's Saturday. We'll probably be off the New Jersey coast on Sunday, if everything goes as planned.
I have a question that somebody messaged me on Facebook. How deep do you have to go before you hit bedrock?
Well, that's a great question. And that depends a lot on where you are in the ocean. So this part of the ocean, the sediment is really thick. You would probably have to go, I'm not exactly sure, but you might have to go a kilometer deep to reach bedrock. And what determines how much sediment there is on the seafloor, in other words, how much mud there is before you hit bedrock, is how old that seafloor is. So some of you probably know that there's new seafloor being created in special places all around the world. And the special place that creates Atlantic Ocean seafloor is right in the middle of the Atlantic Ocean. And so the Atlantic Ocean's been slowly getting bigger over time. And the oldest part of the Atlantic Ocean is actually this part near the United States and Canada. So this is where you'll find the thickest sequence of sediments. As you move closer to the middle of the Atlantic Ocean, the seafloor is younger, and the amount of sediment gets smaller and smaller.
Next question I have is, how many total cores will we get?
Yeah, so that's a good question. I think you guys saw one of these multi-cores, you know, that, call it a web, a spider web? Yeah, okay. So this lander that we put gently on the seafloor, well, it punches 8 separate short cores into the mud. So each time we deploy that, we'll get 8 cores, and we'll probably do about 10 to 15 gravity cores. And there's another type of coring device that I don't think you talked about, the piston coring device. Okay, so when I add it all up, I say we'll have somewhere around 25 or 30 sediment cores when we head back from New Jersey to Woods Hole.
Should tilt the camera so they can see the ones that are down there.
Oh yeah. So here are some of the gravity cores. Oops, can you guys see? Yeah, you can see. And so basically they'll just sit in these D tubes, we call them, until someone wants to collect more samples from them. We've taken the samples that we want from them, but this is a public resource, and any oceanographers, scientists in the world aren't on this early, who want to work on this sediment they can either contact the Woods Hole institution and say, I would like these sediments, and they get sent, or they can come to the Oceanographic Institution and take the sample.
How is the weather?
The weather has been wonderful. It's nice and dry, not too sunny, so we're not getting real sunburn out there, but just warm enough that you're comfortable in your sleeves, maybe a sweatshirt. And most of all, what's most important when you're at sea is the fact that the wind speeds have been really low. So that means that the waves on the ocean are very small. And that allows us to do all of the research we want to do without worrying too much about damaging equipment when you try to put it over the side, damaging the ship, or injuring someone. So the weather's been very nice.
How do you determine which spot is good for coring?
That's another really good question you guys have. So we use a seismic survey. So the ocean here, as I said, is 3,700 meters deep. We have these sound waves that we emit from the bottom of the ship, and they go down to the floor and bounce back up. And when they come back up, change just a little bit, and they've changed a little bit because the sediment at the bottom of the ocean, the seafloor, can either be very, very hard, and therefore this comes back very similar to when it left us, pretty much unchanged because it just bounces off the bottom, comes up. The kind of seafloor we like, where we can get nice long cores, is soft and muddy and clay-like. Well, the sound waves penetrate into that softer bottom, and then when they finally get bounced back up, they almost look like they're spread out. And so we basically use these sound waves that we send down and get bounced back up to determine how much sediment and what the sediment is like below us.
Do you compare the gravity cores to ice cores?
That's a very sophisticated question.
That's from Christine, by the way.
Okay, that's fantastic. Yes, we do. We absolutely do. So the ice cores that are most similar to the types of sediment records that we're going to be generating would be from the summit of the Greenland ice sheet. So Greenland has about 10,000 feet of ice in the center, and you can drill ice cores similar to how we take sediment cores, a little different. that penetrate all the way through that ice. And then people take those ice cores and they analyze different chemical parameters through time and try to determine how the climate varied up in the summit of the Greenland ice sheet over time. The ocean is, the climate records that we can get out here in the ocean are a nice complement to those, but they give us a much more regional picture of how the climate changed over time. The Greenland ice sheet is very far north, and the climate change that occurs there can sometimes be out of sync with the climate change that occurs in the middle and low latitudes of the planet. And so we are able to go to various places in the ocean where we can evaluate climate changes that are more reflective of a larger part of the planet than the climate records that you get in the Greenland ice sheet or the Antarctic ice sheet.
How much more research is done with the mud once you return to land?
Yeah, most of it. Really, for the types of measurements we're doing here, which I think we mentioned are mainly reconstructing the sea surface temperature over time, you can't do any of those measurements out here. When we're out here, we're basically collecting the samples that we bring back to the lab, and then the real work starts. So I showed some sediment cores over here. It might take one of my graduate students 2 years to make all of the sea surface temperature measurements that we would make in that set of cores right there. So most of the work is actually done back on shore, and it can take several years to complete.
Do you interrupt any sea life when drilling/boring? This is from Emma, who's 5.
I suspect no, but I can't say for sure. So a couple reasons why I suspect no. The actual type of sea life that exists in the very abyssal parts of the ocean, like what's below our ship right now, so the sediment cores that we're taking right now, are so deep in the ocean, there's just not much in the way of sea life down there. The type of life that does exist are small invertebrates mostly, very small little creatures that live in the sediments and eat the tasty organic substances that rain out of the surface. It is possible that there are things like marine mammals. We've seen quite a few whales and dolphins out here that would not, probably might be frightened by what we're doing, but it doesn't make much noise. And I suspect that the ship itself is probably more bothersome to them than the type of sampling that we're doing.
And then a more climate change question. Is the ice in Greenland affected by climate change?
Yes, the ice in Greenland is greatly affected by climate change, both in the past and at present. At present, the Greenland ice sheet is melting, melting pretty rapidly. And the climate of the Greenland, or the climate around Greenland, is actually, in some ways, more sensitive to things like increased greenhouse gases in the atmosphere than the ocean is, because everything is amplified at the high latitudes where Greenland ice cores are taken and Antarctic ice cores are taken. And why is climate change amplified at these high latitudes? It has a lot to do with the ice itself. So if you start to melt ice in the high latitudes, then less of the sunlight that normally gets reflected back to space by the ice stays down low and warms the planet more, and that melts more ice, which means less sunlight's reflected back to space and stays down low to warm the planet more, and so there's something called a positive feedback. And so the climate changes in Greenland, both the natural ones and the ones that are being caused by people, are actually larger than the climate changes that occur, say, in New Jersey or where are some of the other students at?
Texas.
Yeah, then in New Jersey or Texas or
New York.
California.
Yeah.
I have an idea.
Approximately, what is the sedimentation rate for the site?
That's a great question. So we won't know for sure. We won't know for sure until we get these the samples that we're collecting back into the lab, and then we'll pick out small little microfossils that once were growing in the sea surface and have died and sunk to the seafloor, and we will actually date those using radiocarbon dating. But so we don't know, but our expectation is that the sediment accumulation rate's probably on the order of 10 or 20 centimeters per 1,000 years. And what we see in the split sediment cores is kind of consistent with that.
Are cores kept in a freezer?
So we don't tend to freeze our sediment cores. We tend to keep them in a refrigerator. And the reason why we tend not to freeze our sediment cores is because, as most of you know, I think, water tends to expand when you freeze it, right? And even though the mud looks very solid and as though it doesn't contain much water, it actually contains a lot of water. And so if you were to freeze it, the ice crystals would cause changes in the sediment layering and structure. And then when you thawed it, it would change again. And so we tried not to freeze the sediment cores because we don't want to change the nature of the sediment and the different layers within the sediment.
How many cores does the PUI repository hold?
I do not know that answer, but I'm going to guess more than 10,000, I would guess.
When we were shown the mud, we were told that it was reddish in color. What makes the mud that color?
Oh, good question. Okay. So many good questions. I'll try to stop saying that. So, so the red color that you're seeing, the reddish color that you see in this, yeah, maybe it doesn't look very red, but it is actually quite red. So the reason why that sediment is red is this part of the ocean gets sediment, or say gets runoff on the land, and the runoff in eastern Canada contains a lot of this red sediment because the rocks in that part of the continent are actually called red beds, and they contain a lot of iron oxide. And it's actually the iron oxide that is giving the sediment the red color. But it is coming from land, so the rocks on the land get weathered, and they're these very iron-rich red bed rocks, and then that gets flushed to the ocean through mostly rivers, but a little bit from icebergs and a little bit from winds that can blow the dust into the ocean. So the red color is iron that's coming from iron-rich rocks in eastern Canada.
Another question I have for you is, have you ever sent the submersible down to watch coring at the ocean floor?
I don't know if that's been done. I have never done it with seafloor sediment coring.
The Nautilus has a coring apparatus that takes a very short core on it.
That makes sense.
Yeah.
So they can sample the sediment around hydrothermal vents.
Yeah.
So if you didn't hear that, there is it's an
ROV.
Yeah, okay. That's an ROV, a remotely operated vehicle. So it's like a mini Alvin that doesn't carry people. And it has a short sediment core that it can punch into the sediment. But my guess is people have deployed cameras on sediment coring equipment and been able to get images of the sediment core penetrating the seafloor. But I've never done it.
I have two more. Have you ever seen a shark in any of your cruises?
Yes, None in the North Atlantic, however. The only places that I've seen sharks, and I've seen lots and lots of them, are when I go to the tropical Pacific. A lot of the research I do is in Polynesia and in Micronesia, and for whatever reason, you tend to see a lot of sharks. They don't tend to be the giant great white sharks. They tend to be more the reef sharks and the black tip and white tip reef sharks. So, but I've never seen any sharks in the North Atlantic, not yet.
All right, last question. How do you prepare the mud to look for alkanones?
How do we prepare the mud to look for alkanones? Well, we take our sample of mud, and the first thing we do is we dry it out, okay? We use a freeze dryer. If anyone has seen instant coffee or something like this, it's typically dried coffee. So we dry it out, and then we put it into a special machine that adds some organics. So things, anyone probably familiar with the smell of acetone, maybe? Anyone who has smelled nail polish or nail polish remover has smelled acetone. So acetone is one type of solvent that we will use. And so we take the dried mud, we put it into a small jar, we add acetone and another type of solvent, and then we apply some sound energy, basically, ultrasonic energy, like the dentist does when you go to the dentist to get your teeth cleaned. In any event, we use ultrasonic sound waves, solvents, and that brings the alkanones out of the sediment. It extracts the alkanones out of the sediment. And once we've extracted the alkanones out of the sediment, we have to purify them a little bit, and then we can do our sea surface temperature analysis.
How long would it take to prep one sample?
Well, we would typically work with 12 or 24 samples at a time, and I would say we could get 12 sea surface temperature reconstructions done in about 2 days.
Awesome. Great. And Allie, you want to show your, yeah.
Show.
So you can go ahead and talk.
Slow-mo says hi. Slow-mo is our class mascot.
Yeah, Slow-mo has been joining us on the cruise, taking group pictures with all of us. So, yes, thank you everyone for joining us. They were some amazing questions. Aaron's over here too. This is our teacher -1. We're missing David, so we've got Ollie, Stacy, Aaron, and David, and myself as the
Thanks for
teacher
hanging
team.
with me on the Facebook Live, guys.
Yes, Aaron is the one manning the Facebook Live pictures, comments. So thank you. Please follow us on Facebook for at Rutgers PUFINS on Instagram and Facebook, where we're posting more pictures. Our blog posts will be posted there, YouTube videos, all of that. So please stay tuned to see some amazing footage. Yes, and please subscribe to our YouTube channel, Rutgers PUFINS. So lots of amazing content coming over the next 10 to 11 days. So thank you, everyone. And we will be back on Friday afternoon. So bye. Say goodbye. All right. Good night, everyone. Your parents say hi, Ollie.
Oh,
Yes. Bye. Thank you, everyone.